explore the principles and best practices for secure and baseline configuration within network security. The importance of a well-defined secure baseline cannot be overstated as it forms the foundation for an organization's cybersecurity posture. We will also discuss how to establish a cost-effective and business-supportive secure baseline, popular security configuration management solutions, frameworks to guide selection, and methods to test and protect configuration files. Secure configuration is one of the fundamental pillars of network security. It involves applying security best practices to software, hardware, and network devices to minimize vulnerabilities and reduce the attack surface. The primary objective is to ensure that all network components operate with the least privilege necessary while enforcing strong security policies. Baseline configuration, on the other hand, refers to a predefined set of security settings that define the minimum security posture required for a system or network device before deployment. A well-defined baseline configuration helps organizations achieve a consistent security standard, ensures regulatory compliance, and reduces risk associated with misconfigurations. Common security misconfigurations such as weak passwords, open ports, unpatched firmware, and default administrative credentials can expose networks to attacks. By enforcing a secure baseline, organizations can eliminate these weaknesses and build a more resilient security framework. Creating a secure baseline requires careful planning to balance security needs with business objectives. A baseline that is too restrictive may hinder business operations, while a weak baseline leaves security gaps. To establish a secure and cost-effective baseline, security teams must first conduct a risk assessment. Identifying critical assets, assessing potential threats, and understating business requirements help define the security parameters for the baseline configuration. The next step involves defining security policies and standards that align with industry best practices such as CIS benchmarks, NIST SP 800-53 and ISO 27001. These policies should address key areas such as user authentication, network segmentation, logging, and patch management. Once the policies are established, they must be implemented across all network devices, including firewalls, routers, switches, and endpoint systems. This includes disabling unnecessary services, applying encryption, enforcing strong access controls, and configuring intrusion prevention systems. Automation plays a crucial role in maintaining baseline configurations. Configuration management tools can be used to deploy secure settings across multiple devices, ensuring consistency and reducing the likelihood of human error. Regular audits and security reviews are essential to ensure that the baseline configuration remains effective. Continuous monitoring helps detect unauthorized changes, misconfigurations, and emerging threats. By aligning security configurations with business requirements, organizations can ensure that security does not become a bottleneck, but rather an enabler of secure and efficient operations. Security configuration management solutions help organizers automate and enforce security configurations across IT environments. These solutions continuously monitor and remediate configuration drift, ensuring compliance with security policies. One of the most widely used solutions is Microsoft Group Policy, which enables centralized management of security configurations across Windows-based environments. It allows IT administrators to enforce password policies, restrict software execution, and configure firewall settings. Ansible, an open-source automation tool, is another popular choice for security configuration management. With Ansible, organizations can define security baselines as code and apply them consistently across cloud, on-premises, and hybrid environments. Chef and Puppet are also widely adopted configuration management tools that enable infrastructure as code. These tools help organizations automate security configurations, apply patching, and ensure compliance with industry standards. For cloud environments, AWS Config and Azure Policy provide powerful mechanisms to enforce security baselines. These tools allow security teams to define and monitor configuration rules, ensuring that cloud workloads adhere to organizational security policies. Using these security configuration management solutions, organizations can maintain a secure and compliant IT environment while reducing the manual effort required to manage configurations. Selecting the right security configuration management solution requires a structured approach based on industry-recognized frameworks and guidelines. The National Institute of Standards and Technology provides detailed recommendations in NIST SP 800-128, which outlines best practices for security configuration management. The Center for Internet Security also provides CIS benchmarks, which define secure configurations for various operating systems, applications, and network devices. Organizations can use these benchmarks to assess and configure their IT systems securely. The Information Technology Infrastructure Library framework emphasizes a process-driven approach to security configuration management. It ensures that configuration changes are properly documented, tested, and approved before deployment. Another critical guideline is the Defense Information Systems Agency Security Technical Implementation Guides, which provide strict configuration requirements for government and defense-related IT environments. Organizations should consider factors such as automation capabilities, compliance reporting, integration with existing security tools, and support for multi-cloud and hybrid environments when selecting a security configuration management solution. Testing security configurations is crucial to ensure their effectiveness in mitigating threats. Organizations must conduct configuration validation using automated tools such as SCAP, Security Content Automation Protocol, OpenSCAP, and NISUS. These tools assess whether systems comply with security baselines and highlight deviations. Penetration testing and vulnerability assessments also play a significant role in verifying secure configurations. Ethical hackers simulate attacks on misconfigured services, open ports, and weak authentication settings to identify weaknesses before attackers exploit them. Once secure configurations are tested and verified, organizations must take steps to protect configuration files. Configuration files often contain sensitive information such as cryptographic keys, database credentials, and API tokens. Encrypting these files using AES and RASA ensures that unauthorized users cannot access Critical security settings. Access controls should be enforced to restrict who can modify configuration files. Role-based access control (RBAC) and multi-factor authentication (MFA) can limit administrative privileges and prevent unauthorized changes. Regular backups of configuration files must be maintained to allow quick recovery in case of accidental misconfiguration or security breaches. Organizations should store backups in a secure, encrypted location to prevent tampering. By thoroughly testing security configurations and protecting configuration files, organizations can strengthen their network security posture and maintain compliance with regulatory requirements. Configuration files and stores must be adequately secured to prevent unauthorized access, tampering, or exposure to cyber threats. Since configuration files often contain critical security parameters, leaving them unprotected can lead to severe security breaches. One of the most effective methods to secure configuration files is encryption. Tools like BitLocker, VeraCrypt, and built-in OS encryption mechanisms can be used to protect configuration files from unauthorized access. Implementing strict file permissions ensures that only authorized users and system processes can access configuration files. Organizations should follow the principle of least privilege to minimize access to configuration data. Configuration stores such as Windows Registry and cloud configuration databases must also be secured. Continuous monitoring solutions should be deployed to detect unauthorized modifications to configuration settings. Version control and audit logging play an essential role in tracking changes to configuration files. Implementing a version control system like Git or a dedicated configuration management database helps maintain a history of changes, enabling security teams to roll back configurations if needed. By implementing these security measures, organizations can prevent unauthorized changes to critical configuration settings and ensure that their network infrastructure remains resilient against attacks. We hope you gained valuable insights into the critical aspects of network security configuration management.